So this first problem, it says to solve using elimination. What that means is we want to try to get the same number, but opposite signs. So I see 3 and 5. If I can make one into positive 15 and one into negative 15, when we add them, they'll cancel. So if I just multiply this top by 3 and this bottom one by 5, we'd get 15x minus 15y is equal to 45. 15x plus 15y is equal to 75. Adding these together, those will cancel like they're supposed to. This will be 30x is equal to 105. Did I do that right? 15 times 5.
120.
That's 120? Yeah, thank you. So that's 120, and then if you divide both sides by 30, you get x is equal to 4. If x is 4, then we plug it back in and figure out what y is. So we get 5 times 4 minus 5y is 15. So this is 20 minus 5y is 15, or negative 5y is negative 5, so y would just be 1. So the test is going to be just like this with different numbers. So if I ask you to use elimination, please make sure you do elimination like that. For the second one, substitution, we're going to plug this in for y. So instead of saying 4 times y, we're going to do 4 times 2x plus 1 minus 5x is equal to 13. And then if we distribute, that's 8x plus 4 minus 5x is 13, or 3x plus 4 is 13. So 3x would be 9, or x is 3. If x is 3, we can plug it back into one of the originals and get y is equal to 6 plus 1, or 7. That's how you do a problem using substitution. For this next problem, when you have to find the x-intercepts, that means you make y 0. For the y-intercepts, you make x 0. And for the solution, you just say where they cross. So I'm going to write the first equation, but put 0 in for y. And we just get x is 4. So I'm going to put 4 along the x-axis right there. For the y-intercept, you put 0 in for x. So I'm going to rewrite it, but put 0 in for x. And we just get y is 4. Connect our dots. That's how you graph by using the intercepts. And then to graph the other line, put 0 in for y. So x 0 is negative 1, or x is negative 1. Put 0 in for x. So we get 0 minus y is negative 1. So y is 1. We'll get a graph that looks like that. As far as what the solution is where they cross. So looking at mine, it looks maybe like 2, 2. Those are the coordinates right there. I think on the answer sheet, I might have put 1, 3. As long as you're somewhere over here, I'll give you full credit. All right. Yeah.
Doesn't matter if I use like half, like 1 point, because the way mine was.
If you want to use half numbers, you could do that. All right, and then these. Oh. Yeah. So we've talked a lot about factoring, and that's pretty much what we're doing with all of these problems. When we're asked to solve, what that means is we want to make it equal to 0 and then probably factor by using trinomials or take out the GCF. So I'm going to kind of go quickly through here. If you need me to slow down, just ask me to slow down. But when you're factoring trinomials, we're looking for numbers that multiply to be 30 and add up to be negative 17. So negative 2 and negative 15 would work. If there's just a 1 in front, you can go right into factoring like this. But if there's any other number in front, like a 4, you have to do the long way, like factoring by grouping. So this, when you set the factors equal to 0, you'll get x is 2. And x minus 15 is 0, so x is 15. For letter B, it's already equal to 0. It's already equal to 0, so we could just go right into factoring. So we're looking for numbers that multiply to be 4 times negative 18 is negative 72, and they have to add up to be negative 21. So if you just start thinking about what multiplies to be 72, eventually you'll land on negative 24 and positive 3. So instead of writing negative 21x, we would write negative 24x plus 3x minus 18 is 0. Cutting it down the middle, you could take out a 4x and you get x minus 6. Taking out a 3, we get x minus 6. So x minus 6 times 4x plus 3 would be the factored form. And then like we've done before, you just make it equal to 0 and solve. So x would be 6. And x would be negative 3/4. For letter C, like always, we make it equal to 0. And this one has 2 terms. So we've talked about factoring difference of squares. And we said that the formula was if you have something squared minus something squared, we just write a plus b times a minus b. So this would be x squared minus 9 squared, or factored form x plus 9 times x minus 9. And then making them equal to 0, x would be negative 9, and x would be 9. So just a lot of factoring. Similarly with D, there's only 2 terms, but remember we talked about 3 different types of factoring. We said GCF factoring, grouping, trinomials, and the 4th one was special cases. So a problem like this, we could take out an x, and we have 16x squared minus 1 is equal to 0. So setting those factors equal to 0, we'd get, let's see, x is negative 1/4, and x is positive 1/4. We're supposed to get 3 answers because the highest power of x is 3. And we did. Doing okay so far? All right. Speaking of factoring, keep going with number 5. So I'm just going to factor everything. And the deal with multiplication is once you factor completely, you cancel the same factors in the numerator and the denominator. So this will just be x plus 9, x minus 9. This will be x minus 9, x plus 2. If you factor using trinomials, x plus 2 is on top and then x. So the way that we simplified is if we have the same thing on top and bottom, we cancel them, and we're just left with x plus 9 over x. For letter B, we could factor this also. So this will just be x plus 7 and x minus 6. The bottom will be x minus 8 and x plus 7. So the x plus 7s cancel, you just get x minus 6 over x minus 8. You can't do anything with the 6 and the 8. You're never allowed to break up like a denominator like this. The only time you could affect the denominator is if you're multiplying the same thing on top and bottom, then you cancel out those factors. Going to letter D, we said if the numbers are similar and you're subtracting, you could switch the order and then factor out a -1. So this just becomes x minus 3 over negative x plus 3. It's close. The way that you make them the same thing is you factor out a -1 from the bottom. And then when you cancel those factors, you get 1 over -1, which is just -1. Which leaves us with C. When you're dividing a fraction, what that means is you multiply by the reciprocal of the second fraction. So this first fraction we leave exactly alone. I don't know why it didn't carry over. This should have been an 18. Does that show up on your sheet too? It shows up as 18. So I don't know why the 8's not there, but all right. So it shows up the way it's supposed to. So if we factor this, this will be x plus 6 times x plus 3 over x minus 8. But when you divide, that's the same thing as multiplying by the reciprocal of the second fraction. So if we change this, this will be x minus 8 over, this is just x minus 9 and x plus 3. So the x plus 3's cancel, the x minus 8's cancel. We're just left with x plus 6 over x minus 9, which is a beautiful thing, right? I mean, look at the mess that we started with. And then once you start canceling things out, it turns into a nice, pretty compact fraction. Yeah. I got a little excited. Okay. I was talking about how beautiful it is and got a little distracted. All right. So that's page 2. So we did 67% of the test in 10 minutes with commentary, full commentary. All right, let's talk about Sally. The questions on the test are going to be the same thing with different numbers, okay? So Sally has, she's looking to go on a trip here. 3 adults and 4 children pay 108, 2 adults and 3 children pay 77. So the way that you figure out how much it costs a group to do anything is it's the cost per whatever, cost per adult, right? Times the number of adults. So if it cost $108 for 3 adults and 4 children, we have no idea how much it costs per adult. So let's let X represent the cost for an adult. That's what we have to find. And Y is going to be the cost per child. So if 3 adults, okay, well, that's the number of adults is 3. We don't know how much it costs per adult, so that's going to be X. And then 4 children, 4 times the cost per children, that equals $108. That's how we set it up. 2 adults and 3 children pay $77. We have elimination. We've seen this before. I'm going to eliminate the x's, meaning I'll multiply the top by 2 and the bottom by -3 to get +6 and a -6. So this will just be 6x plus 8y is equal to 216. This will be -6x minus 9y is equal to 77 times 3. It's -231. So -y would equal 231 minus 216 is 15. So looks like y was child, right? That's why it's important to label and not just throw numbers around. Y would be 15. And if we were to plug that back in, 2x plus 3 times 15 is 77. This would just be 2x is equal to 77 minus 45 is 32. It's not much of a discount, but we save $1. And the adults are 16, the children are 15. For number 7, we have a rectangle whose length and width, and it says the length is, so L equals 11 less than 5 times the width. So whenever we say less than anything, remember that always comes like second, right? So 11 less means minus 11 at the end. So we're going to say this is 5 times the width minus 11. And we're given the area. The area of a rectangle is equal to length times width. So plugging in, we know the area is 12. The length is 5W minus 11 times the width. We're just plugging in for everything that they give us. Well, at this point, we're going to multiply it out, make it equal to 0, and solve it. So if we distribute the W, 5W squared minus 11W, and we'll bring the 12 over so that we get a problem that's equal to 0. So I distributed the W and then I brought the 12 over. Now we have to factor this. And we're looking for numbers that multiply to be negative 60 and add up to be negative 11. So negative 15 and 4 would work. So 5W, if you're wondering how I got that so quickly, I'm not that smart. I have the answers right here. 5W squared minus 15W plus 4W minus 12 is 0. And then what yes?
Where did you get the negative 60?
What we do when we're factoring, it's a good question, is we multiply the first and the last numbers together. That's always going to be the bottom number. And we need to find 2 numbers that multiply to be that, and they have to add up to be the middle number. Does that make sense? Okay, good question. We could take out a 5W, get W minus 3, take out a 4, W minus 3. So factoring, usually when you're doing these kind of problems, there's one answer that doesn't make sense. So if we were to make these equal to 0, width is 3. It sounds, possible. 5W plus 4 is 0. The width would be negative 4/5. Well, that doesn't make any sense. So the width for this problem would be 3. And then if you were to plug it back in and figure out what length is 5 times 3. 15 minus 11 is 4. That's how you do something like this. All right. For number 8, it says 2 consecutive odd numbers. Consecutive means one right after the other. Odd means you can't divide by 2. So that would be like 3 and 5, 11 and 13, 21 and 23. So it looks like to go from one consecutive odd to the next, you have to add 2, right? So we don't know what the first number is. So if you don't know something in math, we use X. The second number, we just said you would have to add 2 to it to get the next consecutive odd. But their sum is 116. Sum means that you add them. So that would be the setup for this problem. X plus X is 2X, plus 2 is 116. 2X would be 114. X would be 57. So your first number is 57, which means your next number, the next number here would be 59. So for this, I don't want you to just guess and check. That wouldn't work for me. I'm grading the work. So for all of these problems, if you just write the right answer down, I'm not saying anyone here would cheat, but if you just kind of look to the side and that kind of stuff, and you write the number down, I can't give you credit for that. So I grade the work. So if your final answer is wrong, That's okay. I still give you mostly partial credit from your work. So please make sure you show me as much work as you can to get partial credit. All right, and then we have one more here, number 9. It says an object is thrown upwards from the top of a 96-foot building with an initial velocity of 80 feet per second. The height h of the object after 2 seconds is given by the quadratic equation this. When will the object hit the ground? It'll hit the ground when the height is equal to what? 0. So if that's the equation for height, we just make it equal to 0, and you could see that it's almost exactly like everything else we've been doing in this portion of the class, right? Make it equal to 0. You could always take out a GCF of -16. So whatever this first number is, it's always going to factor out. So that makes the math really, really easy. This will just be t squared minus 5t minus 6 if you factor out a GCF of -16. And then the way that we solve this kind of equation is we set the factors equal to 0. And if you factor this t minus 6 and t plus 1, like I said, usually you get one answer that doesn't make sense. So if t minus 6 is 0, that means after 6 seconds, the object's on the ground, which sounds like that's possible. This one, t plus 1 is 0. Having negative seconds doesn't make any sense. So the only answer for this would be 6.